Good evening, students. Today we'd like to discuss about the matrix transformations. The basic objective of learning this matrix transformation is basically to find out the inverse of the matrix. Though in our last classes I have defined what is the inverse of matrix, but still today again to recapitulate and to reconnect you, I would like to tell you that what we have already discussed in our last 3 or 4 classes. My dear students, we have discussed the following topics and also we have solved the exercise and the assignment already given to you, and I hope that already you have completed those assignments. We have done identification of element in the matrix. This is already have done. That is A11, A12, A13. That next is matrix classifications. This particular thing is also we have done over there. Particularly we have reinforced and talked about the square matrix, the diagonal matrix, scalar matrix, identity matrix, love, etc., etc. Now, number 3, we have also learned the product of the matrix. Over here also, we have also done conditions of the product of the matrix and also the right cancellation law and the left cancellation laws. After that, also we have covered the transpose of matrix, and then a very important, that is symmetric matrix and the skew symmetric matrix. And also we have done the few properties of the symmetric and skew symmetric matrix. So after learning these 5 or 6 subtopics under matrix, today basically we would like to discuss about the matrix transformations. Now, what is matrix transformations? What is matrix transformations? That I would like to discuss. Now, before learning the matrix transformations, let me tell you that already you have done this in your class 10 matrix syllabus or also in the equations. Let us try to recapitulate what we have done in class 10. My dear children, see, one thing you have done frequently in class 10 to solve the equations. Now, whenever you are solving the equations, whatever you are writing, suppose I have asked you to solve x plus y is equal to 3. Then 2x minus y is equal to 1. And my dear children, you already are habituated to solve these equations. Now, while you are solving these equations, you have done some activities. Now, I want to reconnect those activities, which is very important in these matrix transformations. Now, which activities you have done? You can write these 2 equations alternately in this way. Now, I want to rearrange these equations in this way. 2x minus y is equal to 1. I can write, and x plus y is equal to 3. If I want, I can rewrite or rearrange these 2 equations in this way. Now tell me that is there any difference between these 2 equations and these 2 equations? There is no difference. That means these 2 equations, if I write this way and if I write this way, 2x minus y I have written this above and x plus y I have written over here. So I can easily write these 2 equations. This is called the equation transformations. That is, now the equation number 2 I have written over here. Now why I have done this? I have done this because I want to write this 2 above and this coefficient of 1 in the below. I want to bring this. So if I want, I can do it. Now see, the same expression I also can write in the matrix form. How can I write it? Already I have done matrix product. Now see, I can write this in matrix form. That is, if I write these coefficients, I can write 2 minus 1, 1, 1. And this x and y variable I will write in the right hand side and this will be in the product form. This is a 2 by 2 matrix and this is a 2 by 1 matrix. So this matrix product is possible. And if I multiply again these two matrix, I will get this expression 2x minus y, see 2x minus y and 1 into x plus 1 into y. So I can write this. Now this product is equal to, also I can write as 1, 3. So these two equations can be transformed into matrix form in equational form. That is 2 minus 1, 1, 1 is a 2 by 2 matrix. This is xy. It's a 2 by 1 matrix because 2 rows and 1 column, and this is also 2 by 1 matrix. So I can write these expressions. Now see, if I want to write these equations over here, how can I write it? Then you understand. These equations I can write in this way. 1, 1. So these two coefficients I can write 1, 1. And here it is 2 minus 1. And here it is xy. And that is equal to 3, 1. 3, 1. Now just see that is no, as I told you, that there is no difference between these two expressions and these expressions. Similarly, I can say that there is no difference between these matrix equations as well as these matrix equations. Now here you see what is the difference of expression of these two matrices. Here in the first row I have written 1, 1 and in the second row I have written 2 minus 1. But in this matrix, just you see, I have written 2 minus 1 and here it is 1, 1. xy, this variable in the right hand side remaining the same for both the cases. And here also, in the right hand side of the equations, just you see 3, 1, just see 3, 1 and here 1, 3, 1, 3. That means, basically what I have done over here, from if I want to convert from here to here, I can do it. From this matrix, I can write in this way. Also, I can write this expression in this way. Now, what is the difference between these two expressions? Here, the difference between the two expressions is that the row 1 over here is transformed into row 2, and row 2 of the first equation is transformed into row 1. Just you see, and whatever I have done over here in this matrix, in this over here, the same activity I have done also in the right hand side. Just see 3, 1 and here it is 1, 3. That means the row 2 of the first equation has been written over here and row 1 over here has been written over here. So both these matrix expressions are same. This interchange of row we can do in matrix. This is the first property in the matrix transformation. That is, we can write in this way: R1 interchange into R2. This one, R1 interchange into R2. This language you have to write over here so that we can understand from this matrix we have got this one. So I think you have understood. Now next things, other transformations I want to tell you. Suppose, let's rub this. See, let us write these equations. 2x plus y is equal to 3 and 2x minus y suppose is equal to 3 and x plus y is equal to 1. Suppose. Now, if I want, I can multiply these equations. In class 10 we have done. Now to eliminate this x, if I want to eliminate x rather than y, what I can do? I can multiply this equation into 1, we have done in class 10, and I can multiply the equation number 2 into 2. Why we are doing it? Because to get the same coefficient in both these equations. So over here I can write it as 2x minus y is equal to 3, and if I multiply both sides by equation by 2, I can write 2x plus 2y is equal to 2. So if I write this, so this expression I can write, that is here we have multiplied this by 2. For the same expression, if I write over here, or how I can write? These equations I can write in this way: 2 minus 1, 1, 1, xy as it is variables, I can write it, and here I can write as 3, 1, and over here this matrix I can write, see, 2 minus 1, and here it is 2, 2 is equal to, here I will write 3, 2. So from this matrix, how I have got this matrix? Similar things from these two equations, I can get these two equations before solving. So the same activity I can do over here. What I did over here? I did over here in the second row. In the second row, this 1, 1 I have transformed into 2, 2. How? By multiplying the row 2 by 2. So if I want, I can do it. That is, this activity I can write in this way, that R2 is equal to 2 R2. So the same expressions, just to see the row 2, I can multiply this by 2, 2. And whatever I have done, the same thing I can do over here. That is, the second row on the right hand side also I have multiplied by 2. So these expressions also I can do, this activity also I can do in these are second matrix transformations that we will do it frequently. Third and the last activity or for transformations, what we have done in class 10, again I am trying to reconnect you or recapitulate you. What we have done, children, suppose here what you did, whenever I have got this, I want to eliminate y. What we have done, we can add these two equations. What about this multiplication? We can add these two equations, and if I add, what we can get? We can get these two cancel, we got 3x. Or you say, if I don't know in this way, suppose another way also I can tell you. Suppose one equation is 2x plus y is equal to 3. Another one, suppose 3x plus 3y is equal to 5. Suppose I want to, these are the two equations I have got. If I want, can I subtract these two equations? I can subtract it, that is, this is equation 1, this is equation 2. If I feel I want to subtract, and I can write also 3x, if I subtract, I can write 3x minus 2x x. Here 3y minus y, that is plus 2y, and this equation I have got 2, 5 minus 3, 2. Now, if I want to solve, suppose 2x, again I rewrite 2x plus y is equal to 3. So I have got two new equations by subtracting x plus 2y is equal to 2 and 2x plus y is equal to 3. Now, if I want to write these two matrices and these two matrices, you can say, you can see what? You can see, suppose this expression I can write 3, 3, 2, 1, and here it is xy, and here it is 5, 3. These two equations I can write in this way. After subtracting these two equations, I can write 1, 2, 2, 1. Here it is xy, and here it is 2, 3. Now let us understand what is the difference between these two expressions of equations. Here you see I have directly changed, this is a matrix transformations from these equations. Now over here what I did, here I subtracted from 1 to 2. So here also from row 1, if I subtract in this row 1, 3 minus 2, 1, 3 minus 1, 2. So this row 1 has been transformed into 1 and 2. And here 2, 1 as it is, I wrote over here 2, 1. And xy variables I am writing. And 5 minus 3, the whatever I am doing in the left hand side, remember, always remember, in the matrix transformation, whatever we will do in the left hand side, the same activity, the same operation we have to do also in the right hand side. And that's why 5 minus 3, 2, and this 3 as it is I have written. So these 3 important transformations we have learned today. Number 1, what we have done? Number 1, transformation. So what transformation we have learned? Let us recapitulate, and I am writing over here. That is, suppose 1, 2, 3, 1, this matrix. Here it is, suppose a matrix. I am writing in this way. Suppose this identity matrix. I am not writing or write 1, 0, same order of identity matrix I am writing. So suppose I am over here. Now if I want, so this is 3, this is 1. If I want, what I can do? I suppose I want to interchange these rows, this row 2 over here. I want to bring over here 1, suppose. So what I can do? I can write 1, 1 and 3, 2. Can I write it now? I can write it. And whatever the activity or operations I have done in the left hand side, same thing I have also I have to do in the right hand side. So this 0, 0 I will write in the row 1 and 1, 0 I will write over here. This I can write it, and a variable part I can write this in this way. So these transformations I can write, or we are learning in which language? These transformations we have learned as R1 interchange into R2. These are the first operations we have done in matrix transformations. Number 2 operations, whatever we have done, this is number 1. Number 2 transformation, whatever we have done, that is the suppose R1 multiplications or R2 multiplications. That is, suppose this is 1, this is 3. Now, if I want to make it 0, suppose I want to make it 0. My objective is to make it 0. So how can I do it? I can do what? First, I will multiply this by 3. This row 1, I can multiply by 3. And whatever I will do in the left hand side, the same thing I also have to do in the right hand side. So in the R1, I can multiply in this way this statement. R1 is equal to 3 into R1. So this R1 I will transform into 3R1. That is, this I can write now as 3, 3. 3, 2 as it is I will write, and here if I multiply this by 3, this will be as it is 0, and here it is 1, 0, and I can write this. There is no change over here because both the concepts are 0, 0 over here. Sorry, this is 1. Sorry, this is 1. This is 1, suppose. So this is 3, 2, 1, 1. 1, 1, 3, 2. Here it will be so this is 1. This is 1, 1. 1, 0. Once I reconnected it, I can write this as 0, 1, 1, 0. And now if I want to multiply, this will be now into 3, and this is 0. So in this way, I can learn these second transformations. The third transformation is, if I want to, now suppose subtract. If I want to subtract, how can I subtract it? That is, suppose 3, 3 I will change this R2. If I want, I can write this expression, if R2 is equal to R2 minus R1. Whatever I have learned. So if I write 3 minus 3 is 0 and 2 minus 3 minus 1, I can write this, and this expression 0, 3, and this is 1 minus 0, 1, this is 0 minus 3 minus 3. So these 3 important transformations we have learned today, and in our next class, what we will do, applying these three important transformations, we will basically try to get the inverse of the matrix. And till now, whatever you will do, you will just see this video repeatedly and try to understand these three important transformation of the one matrix. One is matrix interchange of the rows. Number two is multiplication of the rows for both sides, and number three is addition or subtraction. I also can add also. If I want to add this row, I can write also 3 3. Here this R2 I can write 3 plus 0 3, and here it is 3 minus 1 2. If I want, I can do it. And here also 0 3, 0 plus 1 1, 3 minus 3 0. I can do whatever I want. Here R2 is equal to R2 plus R1. Both the cases, in both the places, in the left hand side and right hand side, we have to apply the same type of operations. If the left hand side I have added in R2, same thing also I will do in the right hand side. So this is enough today. I hope you have understood the matrix transformations. See this video repeatedly and try to learn it. Thank you very much.